Sorry about, I don't know if any of you tried to check out the recording, but sometimes there's technical issues. So it took a lot longer to get it in there. Good morning. All right, we will start as we always start, by coming into this place we're sharing together. We will just wait 1 second while Louisa settles. No, it's like, it feels like pressure probably. Sorry. No, yeah, it's all good. No pressure intended. All right, if you would please join me, or at least just stop doing anything. That's all. That's all I ask. Let's end the vicious cycle of production. And just all at once coming into this room. Noticing if you're holding any tension in your shoulders. Are they up towards your ears? And can you just soften them a tiny bit? Let them fall down and back. Noticing if there's an expression on your face. Or any particular tension in the muscles of your face. And not attempting to do anything about that other than be aware of it. That I will ask that you check out your jaw, the muscle up towards your ears where your jaw hinges. Can you loosen that just a few %? Just softening that area. Let's take the last few breaths of our practice together to set an intention for the day. What would you like this day to hold for you? Lovely. Thank you, my friends. Coming out of that practice. Howdy, Mace.
Howdy. Sorry about being late.
It's all good. Glad you're here.
Me too. I slept through 3 different alarms and then rolled out of bed at 9:26. Yeah.
Are you living in the dorms or the
I'm living in West.
Oh, yeah.
It's still not a short trek.
No, it isn't. You have to book.
I was yeah. I got my grandma spring on.
The mall walk.
Yeah, I got my arms.
Yeah, nice. You got white shoes on too. That's perfect for the mall walking.
I was matching.
That's awesome.
Here,
yeah, just glad you're here. Yeah. All right, my friends. So I was asking some folks at the beginning about how the homework is going. So we have 2 homeworks currently open. They're open through Sunday. We're gonna basically spend the rest of the day practicing function. We're gonna spend the rest of the day practicing some function stuff, getting a little deeper into it than the actual problems that you have. It's always better to know how to go deeper than what you're required to do. Is there anything in there that's particularly troubling? Is having that due on Sunday cool for everybody? I think both homeworks are due on Sunday. Yeah, and just let me know if that's not. Yes, hi.
Could we do it like for Monday, possibly?
Yes, yes, but you'll also have an extra thing I'm gonna ask you to do for Monday, but absolutely, it's a reading more than anything. Yeah?
That's fine.
Cool. Beautiful. Would you send me, Katya, would you please send me an email that just says Monday?
Okay.
Then, because I won't remember this.
Okay.
Yeah, thank you. I appreciate that. So I have a request. What I would like you to do to prep for Monday is to, gosh, I think section 1.3, and I've already asked you to do this, but if you haven't, please do. Section 1.3, and this is on lines. Oh wait, does anybody have the book actually open? I need to see the table of contents, because I think there's something out of here.
I have mine.
Oh, okay, cool. Yeah, I need the, let's go to the home page really quick. Of my, no, oh, sorry, but this is good too. Either way, all this is works. You can get the book through My Open Math. Let's go to content, please. And then our text, indeed. Thank you. Cool. You mind if I just real quick, just kind of peel through here, make sure your laptop doesn't fall off the world. Ah, here we go. It would be, yeah. Laptops are hopefully built for. Yeah, so section 1.3, perfect. Section 1.4, I've asked that you do on your own, and I might open up that homework for you and just have that open for an extended period, because that's a review of exponents. So read section 1.3, and remember that there are embedded videos. I'm a person, I have trouble reading. I suffer from diplopia, which is double vision. I've had that for about 4 years or so. So reading is actually pretty challenging for me. And just the way my brain works, I don't know, I'm starting to wonder, do I have ADHD? But doesn't everybody like almost anymore? Just because the world is such a distracting place. We practice distracting ourselves. So I like videos work better for me, and audiobooks too. I just literally cannot read a paragraph without going back over and over. So have this for Monday. So no homework, but Monday will be a lot richer for you if you do this. And then I'm going to open 1.4 on exponents. And I think I'll probably open that through next Wednesday. It's not open yet. It's a very short section. It should be pretty easy. And if you actually remember all this stuff, it should be cake. You probably don't even need to. I would just like get in there and start on the problems and see how they go. I think that's a good way to do a lot of this stuff that is in this first section of class because it's review. But what I saw the other day made me think we need to talk a little more, because there were certain problems that almost everybody was having at some point or another. Good morning.
Good morning, how are you?
I am quite well, Lorelai. How are you?
Good.
Awesome. So what I'd like you to do just right now on your own, and I might ask some folks to share this, answer this question in writing on the paper in front of you. Write a sentence, please. No, that you won't turn in. It's not a quiz. It's a karma-free quiz, but it'll let you know where you're at. And I'm going to ask you a second one. Just take a moment. Write yourself 2 sentences. Or if you need more also works. almost infinitely many ways to phrase this. Texting someone about functions.
No, I got a text saying I had to go into work.
Oh no, oh no, you want me to respond for you?
Nah.
I'm happy to, I'll tell them off.
I already been gone for a month and a half since break.
And they think you're coming in today?
No.
Okay.
They're like, is there any chance you could come in at 2:30? And I was just like, depends how the rest of the day goes.
Oh, so there's actually a possibility.
There's a possibility.
Wow. All right, let's share some answers here. Anyone care to just step in? What did you write? Yeah, Anna.
I wrote that a function is a relationship between variables, including inputs and outputs.
Cool. So, I think that's a great one. I don't know how to use a semicolon. I'm gonna take that out. Inputs and outputs. I like that. Anything special about that relationship?
I just said, I also added that like every input has one unique output.
Yeah, so no particular input goes to different places. Yeah, very nice. Corresponds to exactly one unique output. So remember, the picture for this is not a function. I have x, y, z. These two are not equal. That's not a function. Yeah, nice addition there. Thank you, friends. Those are great. Anybody say anything else? Other language that, because everybody thinks differently, and so just saying things differently can make all the difference. Lorelai, did you come up with something different?
I just put the rule needed to transform an input into an output.
Ooh, transform. I love that word. That's nice. So a rule for transforming an input into an output. Let's write something here. I was just thinking about this morning. So a function, the notation we use is like this. We have the rule name, and then we have a parenthesis and another parenthesis. So this rule name, is F, G, H, all the things we can call it, etc. It's just shorthand for the rule. Here we have the input, and then we have equals, and over here we have a formula, maybe. Formula for how to find output. Cool. Lovely. Anything up there need a little clarification? We're good. Like I said, I really want to spend just a while on this because it's fundamental to what will happen in this class later. How about this? Somebody else can tell me, what's the composition of two functions, f and g, and is there information missing here that you would want to know? So that just got weird, right? You got anything for that, Louisa? That's okay. Cool. You got something for me, Mace?
I'm gonna consult what I wrote yesterday.
Consulting things. Excellent.
So I would just writing out what it would look like.
Anything you want. I would accept so many different answers for this.
G parentheses H parentheses X parentheses.
Okay, cool. Let's start there. Like this, right? And since I said F and G,
No, sorry.
that's okay. It's all right. You're consulting.
Yeah, consulting.
What does this mean?
G of f of x.
Cool, like that. So G of F of X. Lovely things, right? So the word of tells us a function is going on. So Jack gave us the symbols. Lorelai gave us how to read those symbols. What do those symbols mean? What does that mean when we write this? What's happening? Anna, what's
I
that?
kind of think of it as like a set of numbers being inputted into like another set of numbers.
Cool, so say more, please. That's good. Yeah.
So like you would have your G or F, and like whatever that, I guess, range or domain, whatever you want to call it, whatever it equals is being inputted into the other one.
Awesome, cool. So what's the primal input? What's the thing that comes in first to all of this? And maybe that question, I think you might not know what I mean by that question. Is that true?
Yeah.
Yeah, so X, that's all. So
Okay.
it's such, yeah. And I know you know that, it's just the way I gave the question. So this is our input. And then what happens next? What do I do to X?
Put it through the function of f.
Yeah, so run it through the rule F. Whatever F says, square it, add 3, divide it by something. So F of X is the output after we do that. Then what do I do?
You put that through G.
Absolutely. So then that runs through G, and I get G of F of X, and we can write that in this way. Is that the only way I could compose these two functions, F and G? No, what's up, Jack? Yeah, what's the other?
We could do f of g of x.
Yeah. Or, and it's not what we've written here, we might have F, just like Jack said, F of G of X, and that's a totally different order. And so we would say that. Let's go to Lorelai's proposition here, which is F of G of X. Lovely. So here, first I take X, that's my input. I run that through G first. We're working from the inside out. We're peeling an onion inside out. It's the reverse of all of that. So, so we run it through G. I get out whatever that number is or that formula, and then I run that through F. Are these, and also, so that would be notated as F composed with G of X. Inside, outside. Inside is G, outside is F. Are those the same thing? Does it matter what order I do that in? Yeah. Let's see that together quickly. So, actually, let's do it in a really beautifully applied way. So if you could open your book, please, friends, because there's like some word problems that I don't want to pull out. I don't want to write up, I mean. And I'm really looking at chapter 1, problem 29. That's on page 28 of our text. Does everybody have access to that? Good. Okay, cool. Could you please just do that problem? Step 1, process the information.
You said 21.
29,
Oh,
sorry.
29.
Yes, let's do problem 29. It's, you got this function d of p, and you've got another one, c of x. This is a demand function, this is a cost function. Uber business-like. Bless you. 29 on page 28.
Wait, oh,
Yeah, keep going. Yeah, you're almost there. That one.
okay, gotcha.
Cool. So you need to choose one of those four things and understand why you're choosing it. We could randomly guess with 25% chance of getting it right. We don't want to do that. If you get done with that early, what do you think the graph of D of P looks like? Being a business person, knowing some of the essentials of business, could you take a guess at the graph of D? And maybe the graph of C as well. That's a little harder, more businessy proposition I just gave you. Ah, cool. Okay, I was gonna say, okay, got it. You were just writing down the options and then thing. So which graph is this?
I was thinking that, this would be like the cost.
That sounds
So,
good. Yeah, that's a good
this-
cost graph.
Could be like the initial, like this is obviously here, but
Yeah.
as you produce more, it gets less expensive per like unit that you're producing.
Oh, no. Oh, that's man, nice. Very nice. Yeah, it's beautiful. What do you think the demand function looks like?
Probably. So, number of items demanded, since the price is lower, it's probably more demanded, so it's probably like this.
Yeah. Nice.
Yeah.
Did you have a question? Cool, so. Well, let's do it during
Base
P
your flashlights.
versus P, because that's the input
Right
here.
Yeah.
So we're gonna do it versus price. So, as you increase price, what happens to the demand? Usually. Demand, so there's more demand for a new, if you had it.
Sorry.
There you go. No, that's cool. That's cool. That's what we're thinking about. So what would
this
that-
is a 6.
Oh, and it doesn't have to be necessarily of this, just the general. No, it's okay. It's a weird question I just made up on the spot
Okay,
anyway.
so you're just asking in general. Pricing.
Yeah,
Oh,
like what is just the shape of the graph? Does it go, like that or straight or is it like that?
If the demand is going up, then is that what you're asking?
If price is going up, but as
Demand's
price
going up.
increases, there you go. That's what I'm
Okay.
looking for. Yeah, so you can just put a little slash
Okay.
that moves down.
Okay.
Yeah, exactly. That's it. And then what about the cost? That one's a little bit, got some subtlety to it that I didn't even think about until Jack added it to his graph. But it's really good stuff. How are we doing here?
I haven't done anything.
You haven't done anything, okay, cool. But we now we know what our weekend plans will be. When I say we, I mean you.
Yeah.
Yeah, okay. We'll go through this in a bit.
Okay.
How's it going, Caroline?
I'm kind of on the same page as Louisa. I started that, I don't know, like,
That's pretty good. I honestly forgot what the question was.
oh, it was
Okay,
just
we
an
got it.
evaluate, right?
So there's a couple of things going. So this price is not the price of production, but it's the price we're charging folks. And so this is what comes into the D function. So D takes the current price we're charging and gives us a number of how many of these we think will sell,
Okay.
right? And then C of X is the cost of producing X items. So if I set the price at $6, P would be 6. To find out how many I'd sell, I'd find D of 6. And that would give me a price, or excuse me, the number of items that that we would sell. To find the cost of those items, how much is it going to produce? How much is it going to cost to produce those? Then we take that result and put it into the cost function. So I'm going to go through this again and draw some pictures, but you also, I know what your weekend plans are.
Yeah.
Okay. All that. Yeah, this is beautiful. That's the right field, though. I think so. Yeah. And there's an interesting thing I'll point out. The thing that Jack pointed out to me that I didn't catch either. But yeah, that's what I'm looking for. Beautiful. How are you doing, Marla? Yeah, it would. Solid. We do a nice change. Yeah. Oh, look at this, man. Had some business classes. It looks like. That's beautiful. Yeah.
Cool. I was uncertain, but cool.
Cool. Let's go through this, friends. So the first question is determine the cost of production. So let's look at what D does. So here we get the price charged. That's the input. And then we've got some kind of rule or maybe a graph or something that tells us if I charge a certain amount, how many of those things are we going to actually move? And so the price charged is what comes in, and the number demanded at that price is what comes out. And that's our output. So it's really important to notice that this signifies the output. This is your input. And that's kind of what we're practicing right now. And then we come down here, C takes the number of items we're producing. So here the input is number of items produced. And we're throwing this off. You could call that D if you wanted. That's demand. So this is the demand. Not exactly, I guess, really, because we might produce more or less than the actual demand, but so we'll just leave it like this. Number of items produced is the input, and the cost of that production, cost of producing X items, is the output. So when we come down to answer this question, let's look at what do we got for input and for output. So what is the cost? This is the output we're seeking. Output should be cost. Of production when the price is $6. So right now the input is this. the current price we're charging. So how do we get out the total cost? Well, we have to do a composition of functions. So I take the price, $6. Notice that this thing here, this doesn't have dollars as input. That's that top function. The price P is probably in dollars. They didn't tell us, but it'd be weird to do it in cents. Like we throw pennies away these days. So that's P is probably in dollars. And we run that through D, and then we get out D of 6. This is number of items demanded. If we charge $6. What we expect. We can't predict that perfectly, but we can maybe have an estimate based on prior information, last year's sales. If things haven't changed a lot in the general economy, the global economy, which they're always changing, but we'll just pretend they might not have, and we're predicting. So this is the number of items demanded. That is going to go into C, because C can tell me how much it will cost to produce this many items. So then I take this and I run it through C and get C of D of 6. That gives me the cost of total production at $6. So the way to think of this is just slow down, take a look at what's input and what's output. What do I want? Is there any questions on that, friends, at all? Awesome. And then I asked kind of a challenge question. What is a rough idea of what the demand curve looks like? So as price increases, you probably expect demand to go down unless you're in some kind of weird niche. Like, do people still know what Hamburger Schlemmer is? It's like the stupid, they have it at stores and malls where everything is overpriced. You can go buy a $400 beer mug that keeps everything at a certain temperature. So sometimes those luxury items are status items. The more they cost, the more the demand is. But in general, demand is going to go down as price goes up. Demand goes down as price increases. I don't know, are there any maybe subtleties to that graph? I don't have enough knowledge of economics to think about that. And what I mean by subtleties is, these both kind of do the same thing. Notice that both these graphs have the same quality that I just described down here. So it could be any one of those. Business friends, you're the experts. I know nothing. I really can barely balance any of my income, and I just prefer not to know what I have and act like I have infinitely many. Does either of those make sense? Have you learned anything about that in econ? Okay, cool. I'll just leave that there. Cost is the output here. So if what is X? X is the number of items produced. And C of X is the cost of producing those items. Now, I'll get to Jack, your subtlety in a second. Generally, it costs more to produce more things, right? That makes sense. Costs so much to make one thing. Do they still talk about widgets? Because you have really old professors, do they still talk about this stuff? Like old men, women, peoples. So this is the rough feel. As number of things we produce goes up, cost of producing those goes up. But Jack did a nice subtlety on this and turned it into it's the same thing. Cost is going up while number of items goes up. Take a moment and think why that's the case. Why did Jack make that tweak to his graph? What's that?
I'm not gonna answer because I know why.
Well, wait a minute. I think you misunderstand what we're doing here.
No, I was just like,
kidding. What? So what? Do you know?
So like at a certain point of production, it starts to curve out because of like you're creating enough because you're getting like the demand at certain points. At a certain point, the demand is gonna keep like if you change the graph of your demand, it's gonna change like, your cost production.
Yeah.
So like at a certain point, it settles out towards the end. So you're, like your prices or like the cost of making a certain amount of items as it increases, it doesn't always like increase the costs. Like it might be cheaper to make a ton more than like 6 of them.
Absolutely. That's beautiful. I was just giving you shit.
I didn't care.
Yeah,
I'd explain it.
Yeah, it's good. So, Jack, what did you say to me? Because that's absolutely right, Mace.
Yeah, I was just kind of saying like, as you produce like very few, the cost per item is greater than if you were to do like a lot of that item.
Yeah. Once we can produce 10,000 of these things, producing 15,000 suddenly doesn't become that big a hurdle because we've got the infrastructure in place to crank out tons of them. So the costs become minimum, more electricity, right? Hire a few extra folks on the line. So this is probably the most accurate graph we could have here. Nice. Good shit, friends. Awesome. Thank you. Cool. We got more time to do stuff, which makes me very happy. Let's take a look at let's move our brains into a graphical mode as we think about this. So right on that same page, there's two graphs at the top right. Could you please do number 13 and number 16? Using those graphs, I'll try to make little mini versions of them, even though I really don't want to. If it looks like it's supposed to be at a certain point, it is at that point. And actually, I'm gonna add in number 20, just quickly. If we could do number 22, please. inspired to solve. Just turning things around a little bit. Do that almost, if you know what that means, just look at it and see that. But I want to talk about what it means. I think I got that right. Whoops, not so much. Huh, huh. Almost got myself a little surprised there. 1, 2, 3, 4, so I guess that's that guy there. Check out these. First one, f of g of 3 should be 0. G of f of 0 should be 5. I think. Is that, or anybody disagree? Yeah, okay, cool, thumbs up. Makes my morning good. Yeah. Is there anyone who'd like me to walk through how I did this? Maybe I'm just gonna do it anyway, because I think that is a question on some minds. Let's just go through this one here. Input is 0, and the first thing I do to it is apply rule F, right? We work inside out. So if I take 0 and put that in, now remember, these are the inputs on the horizontal, these are the inputs. Vertical is output. So if I put 0 into F, I get out this value here, 0, 4. This is input on the left, the x coordinate, and then that's output on the right. So f of 0 is 4. Then I have to find g of 4. So g of 4, now I go in, now the input on g is 4, so I go down to the g graph, 1, 2, 3, 4. When I plug 4 in there, I get 5 out. And so that's my final answer. For that. Did I? Yeah? Okay, cool. Okay, cool. Sometimes I get confused. Just gently, just be kind to me. I'll be kind to you. Please just be kind to me. Let's be nice to each other. This one here is, I like this one. First thing we take is 0, plug it into G, and I get out 1, 2. So that's G of 2. Then I go to 2, and I ask, what is the output when X is 2? It's 0. Cool. All right. What does that mean? Can somebody say a sentence about what that means? It's a bunch of symbols. What does it mean? This.
Do you want like the sentence for?
I would love a sentence.
X of f is equal to.
So f of x.
F of x.
Yeah, that's cool. This is good. Ben, thank you. Thanks for helping me.
No worries.
I appreciate you. So this is f of x equals 0. What does that mean? That's how you read it. Beautiful. What does it mean? What am I asking? When I say solve that, yeah.
You're basically trying to find what value of x is gonna give you 0.
Exactly. Find the input that gives an output of 0. Lovely. Beautiful. So this is a problem that says find the input x that gives output 0. And of course, we're using this graph right here. Using rule or function f. So I go to F and I say, what gives me an output of 0? 4, exactly. When I put in 4, I get out 0. So the solution here, I'm gonna ask a different one in just a second here. Solution is x equals 0. Whoa, 4, hello, thanks. What if I ask this question? What if I say solve f of x equals 3? Yeah, Mace.
Is there a dot in line with 2 on the f-axis?
So, I'm sorry, can you say that a little bit?
Is there a dot on the where there'd be a second?
I think I know what you're saying.
Like what? Like count up 2 bars up. Is there a line? Is there a dot on that line?
We're gonna pretend there is.
Okay. Then
What do you think it could be?
2.
So 2, and then how high should that be? About right there.
3.
Yeah, beautiful. So you're thinking beautiful. You're thinking about this exactly
Yeah.
the right way. What inputs give an output of 3? Looks like there's 2 of them. So here we have 2 solutions. If x equals 1, we get 3 out, and if x equals 3, or I guess 2, right? It's pretty shitty looking. Let's fix it up. So let's say that point there is 2, 3. So we have 2 solutions, x equals 1 and x equals 2, or x equals 2. Does that make sense? Let me ask another one. Solve g of x equals 7. Sorry. What do you think, Caroline? You're making furrowed brows in the right way. What do you think?
I don't know.
Well, what gives me an out? Is there anything that hits 7 here?
No.
No, right? And that's why you were you were double checking.
Yeah.
That was great. So what do we say?
No real solution.
No solution. Yeah, no solution. Because nothing. Yeah, so beautiful, everyone. So here, there's no solution because no input can give us an output of 7. Nice. Good stuff. Really pushing it. Love it. Any questions on this, my friends? I want to do a quick one more thing to kind of help us answer problems 37 through 44. I think you've got some stuff like this on your homework, so it's a good to review. Alrighty, let's toss these. Let's just go through some basic graphs that you will want to know in your business life. And certainly in this class. Maybe you'll never see another equation after this. That's okay too. That might be great for you. That might be a super happy day. Every day I don't see equations, but not for the next 3 months. So let's just talk about some basic graphs that are good to know. Besides lines, and that's what I want you to read for Monday. We're going to talk all about lines on Monday, do a lot of heavy work with them. But basic graphs. First one is the absolute value function. So I read this as the absolute value of x. I take my input and I find the absolute value. What does that mean? What does it mean? Take the absolute value of something. Okay, what you got?
The distance away from 0.
Oh man, you're saying it in a way my mathy heart just loves. Yeah, the distance away from 0. And a distance is always a positive thing. So this is just always a positive number. So I'm gonna put up what Jack just said, output equals distance between x and 0, and that's always a positive. Distance is always a non-negative thing, I'll say that. So that means it could be 0 or positive. Quite beautiful. So for example, f of -2 is the absolute value of -2, and you basically strip away any signs. If there's a plus or a minus, it doesn't matter. So if there's a minus, get rid of it. Mace, did you have questions? Okay, cool. So in other words, strip off negatives. So when I sketch the graph out, let's take a look at how I would think about that. Here's x, here's the absolute value of x. Absolute value is 0, just 0. Absolute value 1 is 1. In fact, the absolute value of any positive number is just that number. So we get a really beautiful diagonal line right through there, perfectly. And then I come to the left side and start asking the same question. If I take -1 and strip off the negative, just get +1. Take -2, strip off the positive, you get +2. And then I get that side. And that's just a straight line as well. It's supposed to be a straight line. Imagine it's a straight line. Good luck drawing a straight line. So you get this V shape. That's one of the fundamental graphs you'll want to know for our class. Let's knock out a couple others. There's really only a few. I think there's 4, and that's one of the 4. So the other one, so that was absolute value. A basic quadratic. Now quadratic just means a square function. And what do I mean by that? Looks like you take the input and you square it. And that, come down, let's talk about it. So right here, I'm actually reviewing how to get graphs as well when I do this. So when I put in 1 squared is 1, 2 squared is 4, and if I did all those, it looks like this. Now, kind of an interesting thing, and a subtle thing that a lot of people don't think about. If I take a number that's less than 1, so for example, if x equals 1/2, and I square it, I actually get a number that's less than the input. So you see this kind of pulling down here? It's pulling down because your output is less than your input. If they were equal, it would look like this, right on that diagonal, well, this diagonal. And then when x is bigger than 1, like 2, the output is actually growing. Just a little subtlety about that graph. On the other side, if I take a number that's negative and square it, get the same thing as if I didn't have the negative. So we see this beautiful symmetry on the other side. -1 squared is +1. -2 squared is +4. And then this keeps on going. This is called a parabola. Ooh, let me tell you something about parabolas. And this is gonna happen like all the time. I'm always gonna think about something that's related and then tell you about it. So, sorry. This parabola is a conic section. It's one of the conic sections, and the others are ellipses. So conic sections are ellipses, circles, parabolas. I'll get out of the way in a second, friends, on that side of the room. Parabolas, hyperbolas. Why are they called that? Because they all come from the same thing. If I take a line stacked together like my sweet pens. Okay, well I have to, geez Regis, do I have to do everything? There we go, there's a line. If I take a line in space, and I pick a point, and I spin the line around that point, what is that tracing out? If I was kind of doing, if it had tracers, or it was just marking space as it passed through it, what would that shape be?
A cone.
Cone, yeah, it's a cone. Notice if you just see the top half, looks like this. Right, so it's kind of a cone going up. Cones actually have two parts. There's an upper nape and a lower nape. So a cone looks like this. Circle, like so. And there's like the central axis here. And this is kind of indicating you can't see it. Does that look conish? Is that cone-esque? Take two ice cream cones, put them tip to tip. That's what I'm trying to draw there. So a parabola is if I cut this thing, I take a cut and I make the cut parallel to the side of the cone, and then pull that chunk out over here. The shape of this slice, I'll actually bring one in next Monday if I remember. The shape of the outline of that slice there is a parabola. And there's parabola, so that's a parabola that opens up. If I slice down here, I'd have a parabola that opens down. God, what I wouldn't do for a redo button. The first person who comes up with a redo button in life is gonna be pretty sad. If I take this cone and I cut it across, straight across, well, here's a cut right here. I get a circle. If I kind of slant that cut just a little bit, I get an ellipse. So imagine a cut that's not parallel to this side or that side. I get an ellipse. And if I take a cut that is just straight up and down, it's gonna cut the top nape, that. And it's going to cut the bottom nape like that. And you're going to just cut off those edges. That's a hyperbola. You've seen those before, probably in space. You see something like this, right? If you graph y equals 1 over x, if you've ever seen that, it looks kind of like that. What you're seeing is a cone being cut. The axes are actually the edges of the cone. This is one side of the cone, this is the other, and you're just seeing the front of those slices as we cut right across this way. So all that stuff comes from the same place, which is a cone. So we call them conic sections. Good news, you'll never have to do anything with that knowledge in here. Got two more for you. The other one is the square root function. So, I'll call it S to be spicy. S equals the square root of x. Let's get the feel for it. If I put in x, get out S of x. So square root of 1 is 1. Square root of 0 is 0. What's the square root of negative 1?
Imaginary.
What's that?
It's an imaginary number.
It's an imaginary number. Yeah. In fact, square root of negative 1 is a new number called I. We don't use that in business. Great job. But if you want to learn more, take complex analysis with me. You got to get through Calc 2 first in the future. If you ever think, you know, I kind of like this stuff and you want to take more math, let's talk. Happy to help you decide how to do that. Let's move down a little bit further. So it's 1, 2, 3, 4. What's the square root of 4? 2. So got a dot there. And in fact, this looks like half of a sideways parabola that just keeps on going. So that's a good function. And then we got one last function that we want to talk about. and it is the basic cubic function here. Good lord. So I'm gonna call that c of x, and c of x is just x cubed. You take your input and you cube it. So 1 cubed, well 0 cubed is 0, 1 cubed is 1. Now it starts going crazy. It kind of looks like a parabola, but it's faster. It moves up faster. So we got 1, 2. When I put in 2, I get out 2 cubed, which is 8. See, I didn't even make the damn graph big enough. 1, 2, 3, 4, 5, 6, 7, 8. Zip, bam. There we go. What is negative 1 cubed?
-1.
It's negative 1. If you take a negative number and you cube it, you get a negative. Unlike the parabola, where things became positive even though the inputs were negative, over here they stay negative, and you kind of get the same rhythm here. It's going to look exactly like this. So, friends, what to know about this? X squared looks like this. Absolute value looks like this. Cubics look like that. Square root looks like that. That's our toolbox for the next 10 minutes. So now, this little next bit can be confusing. So let's take a minute and be careful with it. So let's say, given this graph, hold on, let me think. Given the graph, got it, of function f of x, let's just start with something like this. Let's say it's x. Let's say it's square root of x. Here's my example. E.g. square root of x. The graph of f of negative x, so if I put negative in here first, that flips the graph over the y-axis. The original graph, so when I say flips graph, I mean the original, over the y-axis. Literally, just flips it. Like so. If I put the negative on the outside, what does that do? So here I'm negating the input, here I'm negating the output. What does that do to that picture? Flip it over the x-axis, yeah, turns it upside down. It takes everything that's a positive output and turns it into a negative output, and vice versa. So this flips graph over the x-axis. Solid. So that is going to look like this, you know, more or less. Got 2 more things. So this is kind of the given for the whole thing I'm about to talk about here. Ooh, nice, I'm making a grid. That's cool. So if I take a constant times f of x, and let's say that c is bigger than 1. So for example, 2 times on the outside, what does that do to the graph? Let's look at, now things get a little abstract. So I give you a function, this guy here, and I say multiply all the outputs by 2. What does that do to the picture?
It's gonna like stretch it, heighten it.
Yeah, it's taking every output and moving it up twice as far, so it's stretching things up this way by a factor of c. So this stretches graph away from 0. And so if it was down here, it would stretch it downwards, away from the x-axis by a factor of c. What if c was less than 1? So c is between 0 and 1, like a half. What does that do?
Shrink it.
Shrink it. Scales it down. Yeah, so if c is less than 1, let's say it's also positive, then this contracts it toward the x-axis. So this flattens graph towards the x-axis. Solid. Awesome. That's a good thing to know. And then what if I have f of x plus some constant k? So I take x, find out what f does to it, and then add k to that result. What does that do to the graph? Now notice the k is on, I'm adding k on the output side. So what does that do to the output? What would this picture look like? Let's say k equaled 1 or something like that. If I just took this, what is this picture? Oh, got the idea. Did you have a? I thought you were doing stuff with your fingers. Sorry, yeah, you were moving it.
It just shifts to the right or to the left, right?
Yeah, you're thinking of on the input side, but yeah, this one shifts up and down if I add on the outside. Yeah, but yeah.
Inside the parentheses?
Inside the parentheses shifts left and right, outside
Up and down.
up and down. Yeah, beautiful. Thank you. So you've actually answered the next question that's going to come. This shifts graph up and down, up or down by k units. So up if k is positive, and down if k is negative. Just picks it all up. So here, that picture that I started with, notice how here it's at 0, 0. So if I was going to look at square root of x plus 1, that just picks the whole dang thing up and moves it up by 1. Lifts it up. And then let's do the slightly trickier part, which is what Katya was actually thinking about. If I take the graph of f of x plus k, this one's a little trickier. So if k is negative, we're going to shift to the right by 2. Or excuse me, by k units. If k is positive, I'm going to shift to the left. So this one's weird. It acts very counterintuitive. Shift graph left by k units. That's pretty much all I wanted to talk about, but I want to practice it in the last 2 minutes we have left together before you're off for like a billion years, right? Isn't it sweet having 2-day-a-week class? I like it a lot. Never going back to 3 days a week. So let's take a look at one of the problems. I would like to do it together because I don't want to just throw you out into the wilderness yet. That's what your homework's for. But it should make a lot more sense if you were struggling with it. So let's take a look at number 37. It says sketch the graph of this function. So let's rewrite this in terms of the basic function at hand. What is the heart of this? What is the basic shape? yeah, I'm not just massaging the board, I'm like pointing to that too there. Yeah, so parabola. So the basic shape is a parabola. Yeah, very nice. And let's just say it's g of t equals t squared, a parabola. Could you please take a second, my friends, and write f of t in terms of this function? So it's going to be g of something plus or minus something. Can you fill in the blanks to make this that? To make it, yeah. Can you fill in the blanks? Yeah. The thing that goes in the triangle is how we're changing the input on this function. What are you actually doing to the input before you square it? And this is what you're adding or subtracting after you do this part. And we'll call it a day after that. Oh, you're fine, Mace, but I appreciate your courtesy. Yeah. Yep. Quite good. And then you could sketch the graph, you know. Yeah, you can sketch the graph by points, but if you use these ideas we were talking about, you just take this graph and do some shifts with it. Help you out so we can call it a day. Let's notice that g of t plus 1 is t plus 1 squared. Remember this function, what does that mean? It says whatever inside these parentheses, let's put a little thing here. I'm going to square it. So what do I got to get this part? I have to put t plus 1 inside here. G of t plus 1 is this. And then that gives me the t plus 1 squared part. I just need to subtract off a 3 at the end. And so now I can take this, if I know what x squared looks like, so let's just walk that through. What is happening here? So here's good old x squared, or t squared. What does this part tell me to do? Is this a left or a right shift? That is a left shift, yeah. It looks like it should be a right shift. It was on the outside, it would, but it's backwards. It's just ass backwards. So that is a left shift by 1 unit. So I'm going to move this over to 1. So at this point, everything is just going to go over by 1. And then I'm going to drop it by 3 units, so down by 3. So I go left 1 unit, this will be easier. 1 unit, down 3 units. And so you're like, well, how do I do that? Well, just look at the anchor points. You've got this point here, which is easy to identify. So 0, 0 goes to -1, 3. So there's my new vertex. That's the low point. And then here, I could get some more points, but we're just worried about the basic feel of it. And I owe you like 3 minutes, and I will pay you back. All right, my friends, please do the work. The only way you can get this, especially if it's taxing, is to do the work yourself. It won't be enough to just be here doing it. So put that time in, pay yourself. Pay yourself, pay future you. I'm so grateful. Thanks, everybody. Week 2, unbelievable.
Thank you.
Thank you.